Have you ever just stopped and thought about the thousands, maybe millions of tiny little decisions your phone or computer makes for you every single day? From dimming your screen to suggesting the fastest route home, it's this non-stop stream of choices. So how does a machine, a piece of silicon and plastic, actually think? Well, we're about to peel back the layers on that very process.
Okay, let's start with a really simple, everyday example. You're about to walk out the door and boom, your phone pings you with a notification. Hey, it's a little chilly out. Might want to grab a jacket. How in the world did it know to do that? I mean, it almost feels like magic, but it all comes down to a surprisingly simple idea. And believe it or not, this is the secret sauce. Every single complex decision your device makes, whether it's guiding a self-driving car or just picking the next song in your playlist, it all boils down to a series of questions that can only have two answers: a yes or a no, a true or a false. That is it. That's the whole game.
This whole concept is really the bedrock of all computer logic. It's got nothing to do with feelings or intuition or guessing. It's all about looking at a condition and saying, without a doubt, is this true or is this false? And this whole world is what we call Boolean logic.
So let's get the official term on the table. It's called a Boolean expression, and it's just any statement or any question that has to resolve to one of two things: true or false. In the computer's world, there is no maybe. There's no gray area. It's all just black and white.
And here's what that looks like in the real world. If we ask the computer, hey, does 5 equal 5? The computer looks at that, evaluates it, and comes back with true. Yep. But if we ask, does 5 equal 6? It checks that and says, nope, that is false. Simple, right? This is the most fundamental building block we have.
And to ask these kinds of questions, we've got a little toolkit of what we call comparison operators. The double equal sign is how we ask, are these two things exactly the same? The exclamation point with the equals asks the opposite, are they not equal? And of course, you've got your classic greater than and less than. These are the basic tools we use to build all our true or false questions.
Okay, so we can get a true or false answer. That's cool, but so what? How do we make a program actually do something based on that answer? Well, that's where the incredibly powerful if statement steps onto the stage. And the structure here is actually really straightforward. You just start with the word if, you follow it with a condition you want to test, that's our Boolean expression from before, then you pop a colon on the end, and on the very next line, you indent. And that's where you write the thing you want the computer to do, but only if that condition was true.
All right, let's go back to our weather example and actually build a little temperature advisor. Super simple. First, we just have to tell the program what the current temperature is. So let's say it's a pretty hot day. We'll set it to 90 degrees.
Now comes the decision. The program asks the question, is our variable, temperature, greater than 85? Well, since we set it to 90, the answer is true. So the condition is met, and the program follows that if path. It completely ignores everything in the else branch. And bam! Here's our result. Because temperature greater than 85 was true, the program executes that indented code and prints out, it's hot outside. It just made its very first decision.
Now that works great for a simple hot or not hot kind of situation. But, I mean, the real world's a little more complicated, isn't it? What if it's not hot, but it's just nice? Or what if it's chilly or freezing cold? An if-else statement only gives us two paths. So how do we handle more? So to handle these more complex scenarios, the ones with a bunch of possible outcomes, we need to expand our toolkit a little bit. We need a way to chain these questions together, creating a bunch of different branches for our program to choose from.
Think about it like assigning grades on a school test. A score of 95 is an A, right? But an 85 is a B, and a 75 is a C. It's not just pass or fail. There's a whole range of possibilities. This is a perfect example of where we need more than just a simple if-else.
And the tool we use for this is called elif, which is really just short for else if. It's a clever little keyword that lets us add as many extra checks as we want in between our first if and our final else. The way this works is the computer reads it from top to bottom. It first checks, is the score greater than or equal to 90? If that's false, it just moves on to the next question. Okay, else if the score is greater than or equal to 80. It keeps going down the line until it finds the first condition that's true, it runs that code, and then it skips the rest of the block completely.
Okay, now, here's where things get really, really powerful. What if we want to combine multiple conditions into a single, more complex question? This is how we make our logic super precise.
We do this using what are called logical operators. There's AND, which means both conditions have to be true.
There's OR, where only one of the conditions needs to be true. And then there's NOT, which just flips the result, turning a true into a false or a false into a true.
And this slide just illustrates the power of this perfectly. Look at the left side. It's kind of clunky, right? A nested if statement. But on the right, using the AND operator, we combine both of those checks into one clean, easy-to-read line. If age greater than 18 and age less than 21. It's the exact same logic, but it's just so much cleaner.
So let's just step back and look at what we have. The crucial point here is that with just these few tools, if, elif, else, and our logical operators and, or, and not, you literally have everything you need to build incredibly complex and intelligent decision-making systems.
You know, this quote from the source material really just nails it. These aren't just lines of code, they're control structures. They give our programs the ability to react, to adapt, to actually change their behavior based on the data they get. They basically give code the power of choice.
So think about it. We started with a simple true or false, and from that, we can build systems that tell us what to wear, that can assign grades, or check an ID. The possibilities are, well, they're basically endless. And it all just starts with a single question. So now that you know the building blocks, what's the very first decision you would teach a computer to make?